Hi, welcome. Hopefully you can hear me now. um, right now, what you see on the screen is some live imaging that I'm doing of NGC 6914. And I'm going to be doing some AstroSharp testing as well. So hopefully everything goes well. Right now, I'm just stacking some images in Cyrillic and Cyril, and hopefully things will work. And we'll just wait for that. But in terms of what I'm imaging, it's again NGC 6914. I think it's an interesting target. I don't think I've ever imaged it before. We're doing 5-minute exposures in HA. It's a monochrome camera. NGC's, the ZWO 294mm Pro camera, and an Optilong HA filter. Not the best filters, like 12 nanometers, but it's getting some nice images here. So we'll see how it goes. You can check out guiding real quick. Guiding is okay. There's a little bit of, I don't know, stuff going on in the RA axis, it looks like. But we'll see. Things. Let's see. Right. To start off, if anybody is going to be watching, I'm going to go ahead and put a poll up. And give me 1 second. What should the question be? All right, there's the poll. Hopefully everybody says yes. Okay. I mean, if you're just joining, got NGC 6914 up, taking 5-minute exposures, and this is just a single exposure. Hey James, how are you? Doing good. Oh, I'm doing really well. Doing well. Can't complain. Trying to get some stacking done here, but Cyrillic is giving me a little bit of trouble. But while we're waiting, we can take a look at NGC 6914. I'm taking 5-minute exposures, so and HA. I think we've got about 5 so far. I think they're looking pretty good. I mean, guiding is going pretty well. There's a little bit of jiggling happening, but other than that, looks good. Have you been able to do any imaging? Haven't done anything since we moved to the new place. Oh, well, moving takes a lot. It's hard. So we just moved as well. Everything's still in boxes, but I was able to get the telescope out. Let's see. Bring back up the images. So too much to be done. Yep. Yeah, there can be a lot of stuff to do after a move, especially if you've got some property that you have to do some work on. Oh my, it's still packed. Yeah. Yeah. It takes a while to get unpacked, I think. So I've never imaged NGC 6914 before. I think it looks, I mean, it getting some good data. So, but the odd clear night has been amazing. The Milky Way is so bright. Yeah, what's the Bortle scale you're at? Is it like really low? I mean, I think you were told me before. I forgot. It's like Bortle 2 or something. Please make for Mac. You know there is a workaround for Mac. I think 2 videos back with the AstroSharp, it talks about how to do it. So yeah, very low. That's good. Let's see here. Yeah, AstroSharp is. You can get around it for Mac. You need to download R though. I've tried it with Mac, but I don't have a Mac machine, so it's really difficult for me to actually get it working. Because Electron is available for Mac, which is what I used for the Windows initially, and I've tried it using a virtual machine and I just can't get it working. So let's see. Trying to get Cyrillic to work, but it's not wanting to do very much right now. I'm not sure why. Like it stacks a little bit of it and then it just doesn't want to do it. So I try again. Maybe it's because I deleted some files afterwards, but I don't know. I'm not sure. Let me try again. So, and James, have you been able to use AstroSharp on any of your images yet? And Samuel, do you have a Windows machine that you could try it on? So I use the old version, but dying to try the updated version. Yeah, you should check it out. I think the updated version is a lot better because you have that aggressiveness slider, and so you can like tone it down a bit, help control the stars. But I have to get my Astro computer out of storage. Yeah, everything's in storage. It makes sense. So let's see. All right. So what we're gonna do, I'm gonna see if I can get this to work. I'm not sure I can. I'm trying to get Cyrillic to work. So let me input the images, and if not, we can try AstroSharp with some older data that I have. But you never know. Never know with this. So, but if this stacks or if it doesn't stack, whatever happens, we're going to test out AstroSharp, the new one. So I've got, if you're not aware, I have been working on the last few days to try and sharpen the stars separately from the DSO object. And I think that works pretty well. But it needs a little bit more testing, some tweaking maybe, and I'll demonstrate it, in this live stream and see what you all think. GC 7635, such an awesome nebula. I wish we could see it from down here. Yeah, I think 7635. Which one is that? What I've got is 6914. Oh, the bubble nebula. Yeah, yeah. That is a good one. I can't remember all the NGCs by name, but yeah. So let's see. Samuel, if you're still here, let me know if you've seen the video on the Mac and see if it worked. I'd like to know if the workaround is working. But I know some people have used it and it has worked. So let's see. Okay. The problem with the C11 is that the stars are always blown out, makes it hard to work in processing, at least for me. Yeah, that is difficult. Or you, so like when you're using broadband, right? The stars are just blown out. I would just dial down the exposures so they're not as blown out. I think that would probably do a lot. Um, the thing is, like, the C11 has a huge mirror, so all those stars, all that starlight is going to be really like it's really easy for that C11 to overexpose the star. So I would just maybe go down. What are the what sub exposure length are you usually using? 30 seconds these days. Oh wow, yeah, that's a that's a pretty low exposure length, and they're still blown out. I used to do 120 seconds. Yeah, I could. I mean, with something like the Pleiades, I think after 120 seconds, even with my small refractor, they can get blown out too. They're just some bright stars. Just have to like really tone it down sometimes. Of course, narrowband is always a little bit different. So I'm thinking going down to 15 seconds. Yeah, that might be a good idea. Depending on the target, how bright the target and it's how bright the stars are. I guess you're in such a dark spot now that a little bit longer exposure might help with the DSOs. So you might even try something like doing two exposures, one exposure for the DSO and one exposure for the stars, depending on, I guess, your signal to noise ratio, which is something you could check out with the app that I created, right? Because with dark skies, usually the limiting factor for exposure length, like how much of a benefit you get out of it by increasing it, is light pollution. If you have really dark skies, then increasing the exposure length can help get you signal to noise, that signal to noise ratio higher faster. But of course, you do care about the stars. The new spot may change everything. Yeah, yeah. So if you haven't tried it yet, I would just test it out, because if you're going from light pollution to no light pollution, the light pollution is going to affect how quickly your sensor fills up with light anyway. So do some testing and see. You might find that like 60 seconds is now fine, and it doesn't blow out the stars as much. So just something to think about. So okay. Yeah, 6914 is what we're looking at tonight. Is this the one that Trevor Jones did a while back? It might be. It might be. I'm not sure. I don't know. I think it's turning out pretty nice. I think I'll have some good data with it. Give me 1 second. Let's see if I can. Get Cyrillic to work real quick. I'm just going to try the HA data with M16 that I had. I'd taken some images of it about a month ago. So and I might not have the correct flats. support yet. I accidentally didn't take flats for this set of data quite yet, so we'll see what happens. I can try use some old flats. Which setup are you using this evening? I'm using I've got an 80mm refractor. It's nothing special. It's like a doublet refractor from Orion that I got in 2016. I think it's in the video where I measure the SNR from the city and from a less light polluted spot. And just my HEQ5 mount with K-stars running on a Raspberry Pi. I have an off-axis guider and the ZW0294 Pro. You can see the weird, I don't know, amp glow type stuff here, but it's not too bad. It usually like you can get it out with darks, but sometimes it's a little bit of a problem. Let's see here. And then okay, give me 1 second. Thinking about stuff. Takes me a while to think about stuff. I'm thinking of getting a bigger refractor. The 72ED is great, but would prefer something with a bit more oomph. Yeah, those small refractors are really nice. I think the main thing with going with a bigger one is the resolution. You get a little bit better resolution. I see you suggest 16 gigabytes of RAM for your app, which Windows OS 64-bit only. Yeah, I think it should work in, I mean, I have Windows 10. I think it should work in Windows 11 too, as well as 10. It might work previous versions. I doubt that you actually would need 16 gigabits of RAM. You could get away with less. But then again, like my laptop has like 48 or 48 gigs of RAM in it, so I just don't know. So I put 16 as a minimum, just to cover everything. I can then use the ED as a finder scope on the ceiling. That's right. Yep. Yeah. It's true. Do you use an off-axis guider, right, James? Is that correct? I have 64-bit Windows 7 laptop with 16 gigabytes RAM. Yeah, you could try it. Download it. You could download it. So let me show you what else you could also do. So if the Electron version doesn't work, and sometimes it just doesn't work, there is this here, this VBS, run.vbs, that will run the portable R that underlies the whole app, and the app sort of automatically. And you should be good with that. The only thing is it has to be in the correct directory. So if you look, let's see, if we look at the code for it, let's see. Oh no, not this code. I think let's see this here, this code. Put in wherever your Chrome executable file is installed at in this chrome.sys line. So delete this and put that in there. Make sure that these slashes are forward slashes, and then that run.vbs should probably work as long as you have Chrome installed. And I think it should work with Windows 7. hopefully that helps. And if any, that should work, I hope. Otherwise, the Electron app, this executable file should work, I think, but I can't guarantee it on Windows 7. Let's see, I really don't have one to use at the moment. I use a Red Cat 51 as a guide scope on the C11. And that's not too bad. Yeah, having another telescope can work too. Once I have the observatory built, I will add an OAG and use it permanently. Yeah, the OAG is good. Just the spacing is the thing that always gets me. Like once I get the spacing, I take a picture of it, so I know exactly how many spacers I need to add to the off-axis guider to make sure that that's focused at the same point as the camera. But you're welcome, short exposure astrophotography. Hopefully that works for you. And if it doesn't, let me know, and we'll see. You can email me. I can't promise anything, but it might work. I might have an older version of Electron somewhere running on Windows 7 that might work, but I can't promise anything. But that run.vbs file should work. Fingers crossed. So okay, let me see. I'm going to give this one last try with Cyrillic, and if I can't get this to work for whatever reason, I'll just open up an older file of M16 that I have, and we'll process it and see what's going on. Let's see, I really battled setting up the OAG. We'll need some time to play with it. Yeah, it's hard. I did too. So I used the Celestron, the big one, the nice one at first, and it worked on, I think, my Ritchie creation, which is fine. But then when I tried to put it onto my Orion ED doublet, there wasn't enough, I don't know, forward focus. I couldn't focus it inward enough. There wasn't enough in focus for me to use it. It was too big. So I had to get a thin, like the thin off-axis guider. And I feel that off-axis guiders are just better in general than using guide scopes or telescopes as your guide scope, because you don't have to deal with things like flexure. And if you have a C11, that mirror is going to shift a little bit as the mount is rotating, and that little bit of shift is not going to correspond with whatever your guide scope is doing. And so that can always be a little bit of a problem and make a little bit of a softer image than you might like. So yeah, but not to say that like I think guiding is better than no guiding. So but I used like a little 50 millimeter guide scope, just one of those small Orion ones at first, and it would do okay. But you could tell every now and then, like the guiding was just perfect. It seemed like it was perfect, but I would still get star trails, and I think there's a little bit of flexure. So that little guide scope just couldn't. I don't know, like the wires were bending it just a little bit, to make the stars not quite perfect. Yeah, the C11 is renowned for mirror flop. Yeah, yeah. So okay, let's see what we got here. Let's see if we've got something going on. There's something going on with my HA data. It's not wanting to stack for some reason. So I'm just going to go ahead and we'll just go ahead and open up the new version and find an old picture of M16 that I had with another camera. So, and we'll see what happens. and it'll be fine. It'll be fine. There should be no issues, I hope. Okay, let me find the old file. Let's see here. If I can find it. Oh, that's an older. Okay, well, yeah, why don't we just go with this? Give me 1 second. Let me get Serial open. And I've got an old image of M8. So taken with like a real small camera. Like it's an older CCD camera that I had. And give me 1 second, I will find it. Okay, and it's a little bit blurry. So this is actually a good demonstration. So here we have M8. If I stretch it, do an auto stretch, you can see that like the stars are just a little bit blurry. Like I think I was using my Ritchie creation at the time. It's when I first got it. And the collimation wasn't good. So things were just a little bit blurry. So what we're going to do is we're just going to first crop the image because we don't want all the stacking artifacts in it. Another thing too, it was really low on the horizon. So there was it was going a lot through the atmosphere too. So let's see if we can get a good crop out of it. And then I'm going to go ahead and turn. Well, I guess we can keep the auto stretch on. Let's just do a background extraction because why not? And the RBF method works fine for me. I'm going to remove the smoothing all the way up. Deep Sky Astro, I think, or Deep Space Astro told me to add dither to keep the gradients from like going wild. I'm just going to add some points all around. Let's see. Like I don't even know if like there might be too much nebulosity here for this to even work really well. Yeah, I think I'm just gonna not do it. I'm just gonna not do the RPF. And we're just gonna do first a stretch, the generalized hyperbolic stretch transform. I think that's fine. And let me go ahead and zoom in. Pick a point to be the symmetry point on the left edge of this histogram. You can see that this value has changed a little bit. And then let's go ahead and start stretching. So let's stretch this, make this pretty aggressive, and then we'll start stretching. Let's stretch it till we think it looks pretty good. Apply, and then zoom back out. And I'm going to pick another symmetry point somewhere around here. Again, the stretch intensity maybe is just a little bit, not be so aggressive on that. And then stretch this. And I think it's doing a good job. Let's see if we want to change this at all. Let's see if this keeps the star brightness down a little bit. I don't know if it will. I think it's fine. It's fine. Okay, so I'm going to go and save this and we'll bring it into AstroSharp. So let me go ahead and save this as a new file. Let me go ahead and put it on a desktop real quick. Place that I can find it pretty easily. And we will check and see how well AstroSharp can do on it. Okay, so I've saved it. I'm going to go ahead and open up and bring it up into AstroSharp. Give me a couple of seconds. I know you can't see anything on the screen right now. There we go. Okay, here we go. Okay, right. We're going to probably need some AstroClean too as well. So there are probably a couple of new things. The actual order of all these sliders is going to be a lot different, probably, when I end up releasing it, but this is just like the working version that I have now. And so we will see how things go. Give me a second to bring up chat again. I lost chat. Okay, so what we want to do, we can see it's kind of blurry. Hopefully we can create a good star mask with this, but things are like really zoomed in because the image scale is really small. Like the image sensor that I was using is like it's a Starlight Express SX825 like camera. That sensor is pretty small. So we'll see what happens. Okay, so we've got this here. I think this is a good preview. And I've only got this for a single core right now because I've only been testing it. But we have like 3 more sliders. So we have this blending threshold slider here, the star threshold slider here, and the PSF for stars here. And what we want to do, what I'm going to do is going to go ahead and put on dual PSF. What I'm going to do to start is just keep the PSF for the sliders of the different, the regular PSF and the PSF for the stars the same at first. Just go ahead to update sliders, and it should process the image. And we should see it in a second. Okay, so you can see it's sharpened a little bit. Now what happens if I go ahead and increase this slider? Theoretically, it should just process the nebula stuff, the nebulosity. But what you will see is that the stars are also affected, which is why we have the blending threshold and the star threshold also, Well, I mean, it seems like, I don't know, do the stars look like they're affected too much? Maybe not. So maybe if I increase, maybe we need just to increase the PSF for the stars too. Yeah, the stars got a little bit sharper, but let's go ahead and move around the image and check how things look. And it's not too bad. I mean, the data is not great, but generally speaking, like, I don't know. You can see it's probably definitely sharpened way too aggressively. So we might want to bring this down a little bit. Okay, I think that's a good preview here. Okay, so theoretically, like when we have this dual PSF option, the stars should be processed differently than the background nebula. Okay, you can see I think the stars got a little bit sharper here. However, that all depends on how good of a star mask everything is, like, the image is using. So it depends on this blending threshold and the star threshold. So if you can think of the blending threshold as like how well, like how aggressive the program is at merging the stars and the nebula. Okay, so what's going on behind the scenes is it's creating a star mask, and then everywhere like it thinks that there's a star, it's going to apply the model, the neural network, on the stars based on the PSF here. And everywhere it thinks that there isn't a star, it's going to apply the model based on the PSF here. Okay, so that's what's happening. Okay? But like, if you just do that, then you're going to have a little bit of, I don't know, artifacts where the two models don't quite always agree. And so you might have really bad like transitions between the nebula and the stars. And that might produce ringing around the stars, even worse ringing than normal. And it also might like just look bad. So case in point, so if we move this star threshold up a bit, all the way up to 20, what that is going to do is going to say, okay, only the brightest part of the stars are going to be considered stars. And everything else is going to be considered nebula. And if we update the sliders, we can see this. Yeah, I can't wait to try it on my stars. Yeah, hopefully it works. It might not be working too well. I mean, I got to work on other images. The data on this image just might be not good enough. But let's see here. Now this star threshold value basically says, okay, once it makes the star mask, how much should it blur that star mask? And that blurring is going to affect this blending threshold. So if we want to blur the whole thing, what's going to happen is like this star here, if it thinks that this is a star, it's just going to be blurred out, right? And so the key is to find like the perfect spot where things are blending well together, like the two PSF functions, the two neural network models are blending well together. Hopefully it'll save time in processing. We'll see. So the stars just might be too bad, like in this image. They just might not like be pinpoint enough for it to like work really well. So, but if we move this down, the star threshold down, then less and less of the image is going to be considered stars. If we move this blending threshold down, again, it's kind of a similar thing, but less and less of the model is going to be applied to the nebula. And so what I would think of this one is like a star ringing type parameter, and this one is like a DSO nebula sharpening parameter. And so the more you go here, up here, the more this nebula is going to be probably sharpened compared to the stars. And then the more you go up here, the more ringing you might have. So the thing is to like bring this ringing down as much as you can. So probably a good value to start with is about 2 or 3 based on limited testing that I've done so far. And so if we do that, I don't know, maybe it's good to like take a snip so you can compare like different versions. So this is this version with a blending threshold of 3. If we move this up, we can kind of compare what it looked like before and after. And I'm not sure there was too much of a dramatic change. So again, the data just might be too bad, like too far gone with this, because the collimation was so bad. Okay, and then once you get like good blending, like it's blended fine, then we can start to move the star threshold down as well. And so you just kind of move it incrementally down. It's how I feel that it works best. You can like move it down more or whatever. And we can just go scroll around the image to check to make sure things are working okay. Yeah, I mean it's sharpening things. I mean, we could just check real quick in Zero to figure out what it thinks the PSF of things are. Give me 1 second. What I want to do is get rid of this so it doesn't try and figure out the pixel sizes. And then we can go ahead and do the dynamic PSF here. It's definitely a lot better. Yeah, hopefully we'll see. So let's go ahead and see if we can find some stars. It's found some stars. And yeah, like, yeah, this, the PSF is very big. So I think like even a star like, you know, like it's like 11 pixels, 11 and a half pixels is probably like the average PSF for this. That's more than I think what the app was designed for. So I've only really gone up to about 8. So the data might be super bad. So maybe we should try a different one, but we can go ahead and download this. We can actually we'll just do 8 and 8 and see what happens. Just because things are so bad. All right, so, and then of course this doesn't matter. And you can see the stars are getting crunched up a little bit. Let's go ahead and do the full image. We'll wait for a second for it to work. And then I'll go ahead and open up things in GIMP. So I was doing some testing the other day with this, and I think I showed this on YouTube. But here's the, you know, Veil Nebula that I always show on a lot of my videos. This is the regular Veil Nebula here. And this is the star mask that AstroSharp creates. So you can see that I think it does a pretty good job at finding the stars. Again, if the data aren't too bad. So if we overlay this, you can see there are some false positives here. But it's finding a lot of the stars. And actually, this one might be the better one, the better example. I'm not sure. Oh, nope. I can't remember which one. This one here is the better example. And like I think it does a pretty good job, and then it applies one PSF to the stars and one PSF to the DSO. All right, so we have the raw image here. I can zoom in a little bit so you can see everything. If I were just going to do like a very aggressive PSF function over the whole image, like 6.79, then I get this. And it doesn't look too good. I mean, this is very sharp. Don't get me wrong. Like all this nebulosity is very sharp. You wonder how it'll do on a galaxy-rich background? Yeah, I do too. I do too. We'll see what happens. but this is very, very sharp, too sharp, and the stars look pretty gross. Now, if I were just going to try and sharpen the stars, then I might use a less aggressive PSF like 2.7 or 2.25 or so, and this is what this is. And like the stars are much better behaved when that is. You can see there's a little bit of ringing some places, but it's not nearly as bad as like this. And so what I was able to get with everything was an image like this. So again, like we compare it to this, you know, the stars are a lot better. And with a little bit more tweaking, like you might be able to even get better stars. There's still some halos. Of course, probably don't even want to be at such a high aggressive 6.75 for this image anyway. Like the image is in pretty good focus. And I don't think that the real PSF is 6.75. I think it's a lot lower. It's probably around, I don't know, I have to double check. But I think compared, you know, like this to this, like, especially when you zoom in, it's not too bad. You get like a sharp nebula and not quite as sharp stars. So again, the trick is finding the right blending threshold and star threshold. Yeah, it is a pretty big difference. Pretty big difference. I think I still have some tweaking to do with it, but I mean, it should be good. Like for example, with the star mask, right? Like there's some false positives here of what it's considering a star. So probably right here. Is that right? Yeah, right here is there's a lot of change in a very small, you know, a very small area. And so it thinks that this is a star, like the way the algorithm works. It's looking for like very large changes in terms of its like like theoretically, like it's like looking at the second derivative. So it's saying, okay, how much are pixels changing this way, and how much are the changes changing? And so when it finds like a local maximum or minimum, it's going to flag it. And of course, here is a local minimum. And so we kind of like, and it changes quite quickly. So I think the solution there, sorry, is just to limit the size of, you know, the scale that we're looking at. So this is just a huge scale. We probably don't want it to be that scale. All right. It's taking a while. Oh, thank you. Hopefully it works. You know, like, I don't know. I mean, everybody says that they're enjoying AstroSharp so far. Like it says, we've got 9 votes and everybody enjoys it. So let's go ahead and open up. You can open up the image of M8 that we're sharpening. Again, it's an old image from a few years ago, so it's not the best. Taken with a telescope that I didn't quite know how to collimate yet. Okay, so here it is in its full glory. You can see it's very blurry. All right, once it's taking a while. I wish I had multi-core set up for the dual PSF so far. I should have just done it in a single PSF with multi-core because it would have been faster because it's both 8. So yeah, I can't wait for you to try it out too. You got to tell me how it does, because feedback is always good. People tell me that they don't like the stars, so I'm working on the stars. So I think the big thing that I also want to do is I think that this second beta model is just better than the PSF models on their own. Like, don't get me wrong, like the PSF models are fine. They're okay. I didn't have, like, I couldn't take as much care in training all of those models because there's like 27 of those, 27 separate models. And so it's hard to find, like, it's hard to make sure that it works really well. Whereas that second beta model, I feel like it works a lot better. It deals with noise better. And it would be good for like DSOs in particular. So if I can get this second beta version to work with the stars, so I can combine the stars and the beta version, I think that would be probably the best model. And then you won't have to worry about like what PSF should I use for the nebula. You just let that second beta model figure it out for you because it was trained on several different PSFs and it kind of like tries to do it automatically. Let's go ahead and check out the image that I'm doing, 6914, how well it's going. So again, this is K-stars. If you're just joining, I'm also imaging tonight. NGC 6914. And so far I've got 14 5-minute subs. And let's just check them out real quick, see how things are going. Got some dithering going on. It's a really interesting region. I've never imaged it before. All the images look good. This is good. I'm happy. Had to start. It looks like a satellite or something here in the corner. Check the guiding. Guiding is fine. It's okay. It's good enough. Guiding is good enough. Okay, so let's check out, see if that image is it's done yet. Yep, here it is. It's, yeah. The preview, it looks better. Preview, it looks better. We'll see. We'll see. So I'm going to download the processed file. And let's see, where do I want to put it? Probably on my desktop. We can open it up in GIMP again. Yes, I think it's always good to, like, when you're saving it, just to like put in like the parameters that you used for it, just so you can, if you ever need to go back, you can also like see, oh, I sharpen this with a PSF of 8 on this image. Okay. Let's see how well it does. I think it looks better. So here's the sharpened image. And here's the unsharpened image. So it looks better to me. It's still either out of focus or poorly collimated, but the stars have shrunk a bit. So let's try a different image. I'll go ahead and try, I'll go ahead and do the NGC 6992, is that it? The Veil Nebula. Real quick, and I'll show you. Just go ahead and change this back to preview. We don't want it to start processing the whole image at once, because that would take forever. And then I have to close the program and open up it again. It would be horrible. Oh, see ya, James. See ya. Have a good day. Thanks. Talk to you later. I've been so engrossed in trying to find this image. I haven't been checking chat. Okay, so let's see. Okay. Here we go. Here's the Veil Nebula. And if anybody has any questions, feel free to ask. I'll try to keep a close eye on chat. Okay, so we have the Veil Nebula here. Again, I already set the PSF to 8, which is way too aggressive. Let's go ahead and find a nice spot where there's some nebulosity, as well as stars. Okay. So the original image preview here, processed image here. Let's go ahead and I'm going to move these sliders all the way up just for now so we can see what happens when we move them down. And I'm going to move this PSF for the stars down to probably like 1.75, and then maybe we'll do this to 5.5. And we'll go ahead and update the sliders and see what happens. Okay, so let's just take a little screenshot of this real quick so we have kind of like what's going on. We can compare it if we had both the same PSF. We'll see how the stars change if they do. They might not because these sliders are pretty aggressive. Yeah, it hasn't changed too much. So from here to here, like I would even say that this, I don't know, like maybe there's a little bit more ringing that you can see here, but it's not very noticeable. So let's go ahead and move this back to like 1.75 that we had. We'll update the sliders. And then what we'll do is we'll bring this blending threshold down. And hopefully what you'll see is these, like, you'll see the stars start to change. So if we bring it down to like halfway. Hasn't changed much. There's like a sweet spot that you have to get to where suddenly like you'll notice it. So things didn't change yet. You can see there. So let's bring it down like maybe like 2.5. Wait for it to process. And I think you can see like, I'm not sure if you can see that, but like, just bring it to compare a little bit. So like it seems like these stars here are starting to blend in a little bit more with the nebula. Okay, and that's kind of like once you see that, like in here too, like this part of the nebula here is not quite as sharp, and like these stars are starting to blend in a little bit more. And so like this is what I mean when it's like the blending threshold, like things are starting to blend in a bit more. So once you see that, then what we want to do is start to bring the star threshold down. So we'll start like bring it down to like 8 or so. And if we compare things again, like to my mind, like things are getting a little bit better in some of the stars, but it might need to be, it's definitely going to need to be lower. So I think a good like like place is probably around 2 or a little bit less than 2 for this star threshold. So let's go down. Yeah, there we go. Look at the stars. Suddenly they're like really blended in. So if we compare this image here to this image here, like it's like those black halos are kind of gone. Okay. But the thing is, like, once we've done that, the nebula is also is not quite as sharp as it was before. You can see like even the nebula was sharper here. It's not sharp here anymore. So what we want to do is we want to play with these sliders. We're probably in the right ballpark, but we can go up a little bit. Again, up is like less blending. I know it's not intuitive. I might change this later so it's more intuitive. But up is less blending, and we might see like things get a little bit changed. So I don't know if you can tell a difference, but like, so now if we're going to go, it was at 3.7, so remember that. So if we go back up to 20, like you might see some ringing again. Maybe not. Okay. So I think we're at a good, I think 3 is good. So what we want to do now, I guess, is change this star threshold to like just incrementally until we get like the perfect sharpness between the nebula and the stars without like their ringing to start happening. So again, I think you can see like there's a little bit of ringing happening. The stars are, the nebula is getting sharper. So if we can bring this down, there's like a perfect spot that we want to find. Now, this is probably near the perfect spot. You might find in the preview that there's like these artifacts that happen. And again, that's just the star mask kind of misbehaving because it doesn't have a big enough area to process, basically. That's all it is. But if you were going to do the full image, I don't think those artifacts would show up. So if I were going to move this up, I don't think the artifacts would be the same. Or at least they wouldn't be in like the same spot in the image. Yeah, so like I didn't move it up very much. Like we should still theoretically be able to see those artifacts if they were there, but we can't. So, okay, so I think we've got some good blending between the stars and the nebula. There are a little bit of halos still. So maybe we bring this down. See if we can get rid of those. Again, a lot depends on whether or not the mask is actually like detecting the stars too. We can go down all the way to 1 if we wanted to and see if that changes. If it doesn't change, then it's probably not detecting that as a star. It does change a little bit. So I don't know. Yeah, I'm pretty happy with that. I'm happy with that. Now I've already got this really processed with the previous image that I'm kind of happy with, which is here. So I don't think I have to reprocess it, but like, let's go ahead and like, so it's here. Is it in this one or this one? Nope, this one. I've got so many tabs. Okay, so it's this one, right? So I've already got this kind of processed. Maybe it's a little bit too sharp. Fine, that's okay. I don't feel like redoing it again, but like I'm gonna take this and put it into AstroClean, and we can see what AstroClean does to it too. So, or Deep Sky Denoise. I'm not sure what to call it. That should be another poll question for those of people who are here. Let's see. I'm gonna end this poll and start a new one. If you guys are here, start a poll. What should I call the cleaning program? AstroClean Deep Sky Denoise. There we go. Okay, so if you're here, go ahead and answer it. If you want to, just type in chat why you think it should be what it should be. Okay. Right, so I'm going to go ahead and open up the one that I've already processed. Okay, so you'll see the sharpened image is now going to be the original image. You can see it's quite sharp. we don't want to sharpen it anymore. Otherwise, we can like super sharp image. And so I do think I want to put do some Astro Clean on it. Maybe some multi-core. And again, with Astro Clean, you can see how much like all these little like noisy stuff here that happened to the sharpening is pretty much gone. Now it is very aggressive. So I'm going to take this down to 66%. Somewhere around there and update it. And we'll see how well AstroClean does. Okay. Do I want more sharpening? I mean, more cleaning? I don't know. No one has voted yet. Okay. Just trying to figure out how much of the cleaning I should do. You know what? Why don't we just do 100% and we can like examine it in GIMP in layers. I think that's a good idea. So do 100%. I mean, 100% wasn't that bad. But we can always tone it down in GIMP if we want to. And I'm going to do the full image preview. And then it should be multi-core. Like my computer is going to kill me for this. I'm streaming at the same time. But you'll see that the my CPU currently is at 100%. So hopefully the streaming isn't affected too much. Okay, and we'll wait for that. And that's going to take a while. It'll probably take half as long as it normally would. So, but this progress bar, like if you remember in the video, the last video I did on AstroSharp, like this bar won't update when it's in multi-core mode. It will just stay here until it's finished, and it'll just go all the way to like 100%. I mean, one of the ways you can check is just going into your task manager and see how many cores are being used. Once it uses fewer and fewer cores, then it should like be ending. So I don't know. Here, let me show you. Hopefully this is showing up okay. So all of these R instances are the different cores. And right now, anything that says R with a percentage next to it is a core that's being used for AstroSharp. So I have, or a thread, I don't know. I've got 16 threads and 8 cores. So it's currently being processed. My computer is not loving me right now. While that's going, let's go ahead and check out how our images are going. Got 18. Guiding is getting better. It's nice. I think, it smooths out over the night as the gears get greased and stuff. So we have 18. If we get up to 30 tonight, I'd be happy. I'd call that a success. Let's go ahead and take a look at the images here. So this was the last one. I think if we can kind of zoom in, stars look round. Yeah, things look good. I think the last time we stopped was 14. So yeah, if you're here, don't be shy. Say something. Don't worry about it. We're all friends here. Answer the poll question if you feel so inclined. Or don't answer it if you don't want to. Such an interesting object in NGC 6914. It's a lot of nebulosity. I like it. Oh, there's a new one. Guiding looks good. Stars look good. Zoom in a little bit real quick. Yeah, that star looks nice. I mean, I only have a doublet, and I don't have a field flattener on it. I just have a vocal reducer. So the stars in the corners might be a little bit, yeah, you can see they're a little bit misshapen. I have some tilt going on too. But unfortunately with my telescope I can't control that. Yeah. There's a little bit of like aberrations in the corners. Cutting is going well. One thing that I like about K-Stars is that like it's just a good program. Like you can do everything in it. So if you're using a sequencer, like the scheduler, if you were going to use that, like it can verify the image position, like how many ever frames that you wanted. So if like it ever drifts out of the field of view, it'll try and refocus or like realign things. There's another one. Okay, let's check out. Oh, there it is. It's done. Okay, let's download it. We'll take. Right. Let me go and save it. And we'll open up in GIMP again. We'll see what the denoising looks like a full denoising. Here it's open. All right, so this is the denoised image. I think that looks pretty good, honestly. Like there's a little bit of stuff, but we can compare it to like the sharpened image. Like here's all that noise. Like I don't think I could do that in GIMP. Like, or if I did, it would take me forever to do it. So it would take me forever. Again, we can toggle it back on, and everything just like cleans up really quite nicely. So let's just go through it real quick. So this is the original image. Go around it a little bit. Here's the sharpened image. It sharpens okay. This is again with a dual PSF sharpening. And I think I over sharpened it. Like I have a tendency to over sharpen things. That's just the way I do it. But again, like just to recap, like the stars are sharpened differently than the nebula is. So we don't get quite as bad degraining. So if we were only going to use one sharpening model, like on the whole image with just one PSF, it would look like this, which like looks horrible. And then after that, we took it into AstroClean and we cleaned it up. And I mean, it might be a little bit too aggressive on the sharpening and the cleaning, but again, you can control how aggressive you want it. So yeah, let's just test the original. This is the original, and this is the final image. You can see like a lot of the stars have disappeared. Like it's gotten rid of all of the smaller stars. So if you wanted to, you could, again, just take that slider and just make it less aggressive or whatever. But I think a lot of the stars go away in the sharpening stage. So again, on this stage, you probably would want to not be so aggressive, like with the aggressiveness slider, to make sure that the smaller stars still pop out. And then we clean it up. It looks pretty nice, I think. I don't know what you all think. Maybe it doesn't look nice to you. Maybe it looks horrible. I think it looks okay. I think it looks nice. For a free program, I think it's, it's pretty good. Of course, now I would say this with a grain of salt, of course, like that guy created the program. So like I put a lot of work into it. So I don't want to think that it's a bad program. So it might be a bad program, but I don't know. When I started it project, like I didn't think it would work nearly this well. So it has exceeded my expectations. Just because it has exceeded my expectations doesn't mean it's a good program. So, but yeah. No one voted. That's okay. So that's it. Well, I think that's enough for tonight. I got work tomorrow, and hope you all enjoyed this. Hope you enjoyed the sneak peek. Yeah, if you have any feedback, feel free to email me. The email is on my YouTube page. So email me the feedback. Let me know how things are going with AstroSharp if you've used it. What other features you might want to see in AstroSharp. And yeah, Hope you guys have a great week and clear skies.